In this video, we'll talk about writing code that doesn't just work but works well. The kind of code that's clean, maintainable, and doesn't make your future self want to tear your hair out. So let's dive into 10 coding principles that will elevate our code from average to great. Let's get started. First thing first, coding style. Think of this as a shared dialect within a team. Every language has its style guides. Python has PEP 8, Java has the Google Java style guide. And sticking to them ensures our code is consistent and readable, no matter who's working on it. We can take it a step further by using automated code formatters. Tools like Black or Prettier can automatically apply these style guidelines, saving us time and mental energy. This way, we can focus on what truly matters, the logic and functionality of our code, while maintaining a clean and consistent code base. Next up, comments. We've all seen code that looks like a puzzle, making us scratch our heads in confusion. Let's aim for clarity and avoid making such puzzles ourselves. Remember, code tells you how, comments tell you why. Our main goal should be to write clean, easy to understand code. But there will always be times when extra context is needed. That's where helpful comments come in. They explain the reasons behind design choices, make complex algorithms clearer, and give valuable context for future developers. Some open source projects such as Postgres, SQLite, and Django have great examples of good commenting habits. Robustness is key. Our code should be able to handle unexpected situations without breaking. This means adding proper error handling to prevent crashes and unpredictable behaviors. Think about resource management. We need to make sure resources like memory, file handles, and network connections are used and released correctly. Techniques like RAII in C++ and defer in Go can be very helpful here. Another important aspect is defensive programming. This means thinking ahead about possible errors and taking steps to handle them. Checking input, using guard clauses to fail fast, handling error fully, and using assertions are all useful tools here. Now let's talk about solid principle. These 5 principles are single responsibility, open-close, list-cuff substitution, interface segregation, and dependency inversion. Think of them as blueprint for writing code that's easier to understand, change, and add to. Solid principles help create code modules that work well together, but aren't too dependent on each other. This makes our code more organized and easier to test. They're especially useful when working with others. While we need to watch out for making things too complex or adding too many layers, using solid principles carefully can make our development process better. Speaking of building trust in our code, let's talk about making testing easy. Good code isn't just about what it does, it's also about how easy it is to test. When we design a component with testing in mind, keeping them simple and clear, we're setting ourselves up for success. Remember the single responsibility principle? Smaller focused pieces are naturally easier to test. And don't forget how powerful automated testing can be. With good test coverage, we can change and add features with confidence, knowing that if something goes wrong, our test will find it. Abstraction is the art of hiding complexity. We should definitely use abstraction, but like most things in life, balance is key. Too little abstraction can lead to messy, tangled code, while too much can create unnecessary layers and make it hard to understand what's really going on. For example, imagine we're working with different database systems. Instead of writing specific code for each one, we can create an abstract database class with common actions like connect and query. Then we can make specific subclasses for each database, keeping our main application logic clean and separate from the details underneath. Design patterns are like tools in a toolbox, useful when used right, but not every problem needs a sledgehammer. They offer smart solutions to common problems, but it's important to choose the right pattern for the right job. The model view controller pattern, for example, is great for splitting up data, presentation, and user interaction. But remember, not every problem needs a complex solution. Sometimes a simple solution is the best one. Minimize global dependencies. Global variables and instances can lead to spaghetti code and make it hard to track down bugs. Instead, use local state and pass parameters. This makes our code more organized and easier to understand. For example, instead of directly making an email service within our notification module, we can define an email service interface and inject a specific implementation. This allows us to easily swap out different email providers or use mock services for testing without changing the main notification logic. Software development is an iterative process, and our code should reflect that. Refactoring is like preventive maintenance for our code base. By addressing issues like duplication, complexity, and poor naming, we prevent technical debt from building up and make our code easier to understand and modify. This saves us time and effort in the long run, especially as our project grows and evolves. Last but not least, let's talk about security. Always keep it in mind when coding. Watch out for common dangers like SQL injection and cross-site scripting, where attackers can sneak bad code in an application. To prevent this, validate and sanitize user input. Use safe techniques like parameterized queries and output encoding. Also, protect sensitive data. Only collect the personal data we really need. Security is everyone's job. By writing secure code, we help keep our users and applications safe. If you like a video, you may like a system design newsletter as well. It covers topics and trends in large-scale system design, trusted by 500,000 readers. Subscribe at blog.bybygo.com.